Hello and welcome. In this video we are going to focus on three components that we come across in GCSE physics, and those are LEDs, LDRs and thermistors, and we're just going to have a look at a couple of features about them and maybe a couple of uses for each. Now the first one I have here is the LDR, and that stands for light dependent resistor. Sometimes people call it a light sensor, and the symbol for the LDR is this here, which we've come across before in another video, and it might look a little something like this if you saw a picture of it. This picture is not so important for you, but certainly knowing the symbol for it is important. You do need to know that. Now what does a LDR do? Well, you need to know about how the resistance of this changes when you change the light conditions. So if we were to draw a graph, it would look a little something like this. Now obviously we need to label the axes here, so down here we have light intensity, and that means the higher the light intensity the lower the something, and the something over here in this case is the resistance. So at a low light intensity, in other words when it's quite dark, we have a high resistance, and that means we're going to have a low current. So if you've got a high resistance, the current's going to be low, whereas for high light intensities, in other words when it's quite bright, we're going to have a low resistance and therefore a high current. Okay, so that's how this works. Now you could quite easily look at various different kinds of light dependent resistors, or LDRs, and you might get different graphs. So for example, if I took another one that's like different characteristics, you might see that it went a bit more like this. So same pattern but different values for the different light intensities. Okay, so that's an overview of this. The next one to look at is what we call the thermistor, and the thermistor is sometimes called a heat sensor or a temperature sensor, and it looks a little something like this. This symbol you do need to know, and you should be able to label and recognize that. They have various appearances. Here's a couple that I've just drawn out that I've seen before, but that's again not so important. It's just there so you know roughly what these things might look like, and the graph for this one looks very similar, and again we need labels on the axes. So here we don't have light intensity, we have temperature, and along the side we have again resistance. So as we increase the temperature we get a lower resistance, and that means a higher current can flow. Similar pattern to the LDR, but the different variable on the x-axis there. So here we have high current. I'm just going to use the letter I. Hopefully you remember that means current. And down this end we have low current. That's because of the characteristics of this thermistor. Now for the black one we might have a graph that looks like this. The green one might look a little something like this. So we have slightly different characteristics for different thermistors, but again the pattern is the same. The higher the temperature, the lower resistance, and that lower resistance allows current to flow. Now the last one to look at is the light emitting diode, often called an LED. The symbol again for that you need to know. It looks like this. We have a positive end and a negative end, because for a light emitting diode, just like a regular diode, it will only work when current flows in one direction. The difference between a diode and a light emitting diode in terms of the symbol is that we've got these two arrows here just to show, I guess, light coming off. What one might look like in real life is something like this. It can come in various colors, in white light, green, orange, various other colors, and we often have one lead longer than the other to show which side is positive and which side is negative, but that's the light emitting diode, and that's a symbol for it, and that's what it might look like. Okay, so just to move on to a couple of uses of each, we have our light dependent resistor, or our LDR, so what we called possibly a light sensor before. Now the kinds of things that we might use these in, or the kinds of circuits you might use these in, are for perhaps automatic lights. So you could set up a circuit where when it gets dark a set of lights come on automatically. You could have it set up, I've seen it, an example of it for camera shutters. So when the shutter opens to take a picture, if the light is low, the shutter will stay on for a slightly longer time so that more light can come in to take the picture. I've also heard it used for fridges, so when the door is open the light can come on. But memorizing these individual examples is not so important. What you should remember is that when we have a high amount of light, current can flow because the resistance goes down, and vice versa, as explained in the previous slide. That means if you understand that, that means you can look at a question where you might have to apply that idea and make sense of it. Okay, now for a thermistor, what kind of uses do we have? Well, we can have that in automatic heating systems. So if the temperature goes too low, then that means a heating system will be turned on. This detects the temperature and will switch on or switch off heating systems. I've seen it for homes. We can have that. Incubators. Right, the handwriting is looking quite scraggy on this page. Let me just tidy that up. There you go, that's a bit better. And so heating systems for homes, possibly for incubators. By incubators we mean perhaps when you have premature babies, they have to be kept in these little incubators to keep them nice and warm. So this can be used for those kinds of things. Now remember, the key point is not to necessarily memorize all the possible uses for these thermistors, but more importantly how they work and how you could apply it to a system that might be new to you. And all you've got to really remember is that the higher the temperature, the lower the resistance, so the more current that can flow, again as described on the previous slide. Now the only thing I want to really talk about with light emitting diodes is the fact that they are very efficient, and they can be used for lighting systems. If you think about a filament lamp, and by filament lamp I mean these things here. These are filament lamps, small ones that you might find in a torch or something like that, and ones that are used to light rooms in your house or whatever. These are called filament lamps, and they are often less than 10% efficient. That means out of all the electrical energy that goes in, only around about 10% or less is converted into light. The rest is wasted as heat. So with LEDs, they are more nearer 70 to 80% efficient. That means of the amount of energy that goes in, most of it, or up to 3/4 or more of it, is converted into light energy. So they can be used to save energy because less energy is required to light up a room or something like that. So that's one potential use for those things. Okay, so that's an overview of those three different types of components that you might find in electrical systems. That's me just about done for this video. Don't forget to check out www.my-gcsescience.com for a list of all the videos that are related to the GCSE science course. Thanks for watching, and I'll see you again soon.